27, integral from 0 to infinity, dx over x to the fourth plus x to the 2/3 power. Why is this an improper integral? Well, this limit's infinite, so that makes it improper, but also there's a domain restriction. X cannot be 0, so this lower limit also makes it improper. So we have to be careful. This is a double improper integral. Both limits make it improper. Okay? So we have to rewrite this as integral from 0 to some finite value. So I just picked 1. dx of x to the fourth plus x to the 2/3 power plus integral from 1 to infinity, the same integrand. So we got to split this up and evaluate them one by one. If both converge, this original guy converges. If even just one of them diverges, this integral, the original integral, diverges. Okay, so let's go through the two pieces. Let's go through this first one first. How do we determine if this one converges? Well, we can do a comparison test, okay? Our function, 1 over x to the fourth plus x to the 2/3 power, is less than or equal to 1 over x to the 2/3 power for x is between 0 and 1. You can just imagine, even though the value of x is quite small, we're adding something into the denominator. So the denominator is going to be bigger, which means we're dividing by more. And so the final value will be smaller. Okay? This guy, you might know it converges under the same limits of integration, but we can just probably need to actually evaluate it. So integral from 0 to 1, dx of x to the 2/3 power. We write this in the limit notation, do the power rule, fundamental theorem calculus, all that business. You get that the limit is 3. So our guy, this integral converges by comparison test. Since this guy converges, our guy is even smaller by this inequality right here on this interval of x. Our guys can converge as well. Okay, now this piece over here, this was actually the easier one to do a comparison test on. 1 over x to the fourth plus x to 2/3 power is less than or equal to 1 over x to the fourth, where x is greater than or equal to 1, the same reasoning as above. We're going to be dividing by something bigger, so the final value is smaller. And we know the integral from 1 to infinity dx of x to the fourth converges. This is power of 4. The power needs to be greater than 1 for it to, this pattern, this x to some power, that function, that power needs to be greater than 1 for it to converge. So our guys can converge as well by comparison test once again. Since this guy converges, our guy's even smaller, our guy's going to converge as well. So therefore, the original integral converges. The two individual pieces converged.